Appreciate y'all coming. My name is Donald Jacques. I am nicknamed the Duck. If you want to find out about that, see me after. I'll be glad to tell you. I am with EarthSeed Incorporated, CEO, current resident med scientist. EarthSeed Incorporated was established, I guess we got the idea many years ago, and I decided, after reading a lot about the challenges of sustainable living beyond the biosphere of Earth and on the frontier of the Moon, Mars are innumerable, and most challenging are the issues involved in daily tasks to maintain the habitat or the home, especially in light of the wilderness and the little timely contact with others people will have back home. When we look at, it didn't move, thank you. When we look at either the Moon or Mars, with the estimated time involved in travel to Mars between 5 to 9 months, any human habitat must be self-sustaining at its establishment. Not only is supply an issue, but the day-to-day operations of the habitat represent challenges in air and water quality, maintaining food supplies, and processing waste materials. The ability for local personnel to prosper after initiation of their habitat is dependent on the successful implementation of an integrated collection of systems, including power production, food production, recycling, as well as healthy waste processing, much like what our doctor was talking about in the previous presentation. Thank you for a lot of that. All this to afford the inhabitants the time to complete research at the site, all the while maintaining a manageable level of comfort. The mission of EarthSeed is to build the methodology and technology to first survive, then thrive, and ultimately grow beyond the Earth. We will do this first on the Moon, then Mars, and after on destinations further out, such as Saturn's moon Titan, Jupiter's moons Callisto and Ganymede, and hopefully by then we'll have a star drive and we can go outbound. To accomplish this, we are working to create what we call a seed of life, a biome that is a collection of species collaborating to survive as a whole, much as we have experienced here on the Earth. Our functioning system is designed around the understanding that there is a connection between the various species contained within our habitat. As well, that connection facilitates a web of life that moves matter and energy through these various species to provide a foundational seed of life. Each stage of our development has evolved from this important design. Our early research in the years between 2010 and 2014 was studies in hydroponics, aquaponics, hybrid systems, with specific goals of this research were to develop a low-power, single-pump circulation system with artificial lighting, as well as define the selection of companion species suited to a 90-day to-harvest crop rotation cycle. The crop selections were to include at least 2 fish species, a reasonable variety of leafy, fruiting, and root crops. Our first prototype developed were refined and applied to our tiny home integration prototype during 2014 through 2018. This prototype was a 4x8 trailer constructed specifically to house a habitat for one. While never intended to be functional for living in, rather to test the integration of the assembled components. It was painfully clear how claustrophobic the closed environment became when the door was closed on the windowless unit. Even by integrating a desk Murphy bed combo 4x4 slide-out section, the tiny home was microscopic by comparison to most other efforts, with a total active space of 72 square feet. At the New Worlds Conference in 2016, we were able to present our tiny home integration prototype. In March of 2017, we acquired an 84-passenger school bus for our next phase. The tiny home has since been retired, and what was learned was transferred into the Mobile Analog Sustainable Habitat, or MASH. With updated components, we first presented our MASH demonstrator at ISDC in 2017. In the spring of 2019, we initialized our first mini farm inside. The MASH is equipped with the basic necessities for up to 3 adults: bunks, sink, toilet, a basic kitchen, and I do mean basic, with fridge, 2-burner hot plate, microwave, and a sink. We added a workbench with an appropriate tool and material storage inside to facilitate work on the garden and pond. And the garden itself is designed as a collection of 4 individual garden beds with both horizontal and vertical components. The vertical components are used for the growth of leafy plants that tolerate near continuous water contact. The horizontal bed is used for fruiting and root crops. Beneath the garden bed is our fish pond. The pond has a capacity of nearly 200 gallons, uses a single pump to lift water through a radial flow settlement filter to a manifold serving as a biological filtration for our nitrifying bacteria. The manifold drains directly into the vertical planter columns, supporting our leafy crops, flowing directly into a tray of composting components, followed by draining into the bottom of the wicking media bed. The water fills until a maximum depth and the bell siphon engages to drain the bed directly into the pond below through a linear waterfall. 2 linear aeration stones assure oxygenation of the water for the fish, and we've installed an automated fish feeder that provides a measured feed for the fish on a regular twice-a-day feeding schedule. While the feeder is capable of providing nearly a month's supply, it is monitored on a daily basis to prevent overfeeding and to assure that the feed that is provided is consumed by the fish. During the summer months, we began adding our other species, some catfish and some snails for cleaning the tank. For waste processing, we are modifying a porta potty to be used as a modified composting toilet. This will follow much of the other multi-species projects in that there will be not only a composting toilet, but it will also provide homes to black soldier fly larvae as well as red wiggler worms in order to consume the human waste and also food waste that is provided. We are constructing a 5-stage water filtration unit that will process water directly from the fish pond to provide potable water for the habitat. The objective being, of course, we don't want to lose anything. So we're going to recycle each and everything that comes in and through the habitat. For power, the tiny home originally was equipped with a 45-watt solar panel and 2 batteries, feeding a 2,000-watt inverter for 120-volt house power. The Max is installed with 8 solar panels that produce approximately 2,400 watts of power. That is fed 2,400 watts of power at up to 62 volts for our charge controller, providing nearly 200 amps available. The storage system consists of 10 deep cycle 225 amp hour 6-volt batteries configured in a series parallel manner in order to provide us a potential of 1,125 amp hours of use. At 12 volts, served through a 3,000 watt inverter, providing 120 volt house current. And there's our battery system there. The power system functions well, providing just enough power to maintain the pump and lighting system throughout one day-to-night cycle without resorting to shore power. We are regularly adjusting run times to reach a point where we can have a net positive power available in the morning so that we can work towards more stable power management. And to give you an idea of just what we're dealing with here in the picture, you can actually see the feeder is in the center there. But we have that outlet box, as you can see there, operates 2 fixtures underneath the garden bed to provide light to the fish pond. We have the 12 fluorescent tube fixtures above. We chose fluorescence because the lumen output of the fluorescence outperforms LEDs so far. The power usage is a little higher, but by moderating it and adjusting it, we are getting the lumen requirements for the plants, but we're maintaining our power requirements at least in a medium point. We're still tweaking that as we go along. What you see here are 2 of the 4 beds that will ultimately be installed. As I said, the fish pond holds up to 200 gallons of water. there will eventually be a second fish pond on the opposite wall and a separate set of 2 additional row beds. The plan is to actually rotate crops between all 4 beds and give us a full year's cycle of crops. The theory being we can produce enough food in between the fish pond and one of the 2 grow beds for a few months, assuming that we can get the density of the plants that we're working on. As of this date, we've gone through 4 plantings. We're struggling with our pH issues on the plants, and after a year, we have realized that our actual bed is probably full of solids and other things that are now contaminating and raising our pH. So we are actually preparing to migrate the bed on the right into the bed on the left and rebuild the bed on the right. And hopefully we'll get back to where our pH line is back in line with where we want to be. We had actually our first catastrophic failure this past year, and it gave us rise to one little fish who actually still lives. We had a crop of a little over 84 fish as that we installed in the tank back in February. In about March, we discovered a needed mechanical repair to the bus, and it had to go into the shop. So we drained the tank, moved the fish into a unit on the back patio, and thought we had them all. So the truck went into the shop for 2 weeks, sat there for a week while we got everything finalized, another week to get it moved back to its normal parking place, and then it took another week to get the fish pond reinitialized and ready and cycled for the fish to come back home. When I got that bus back to the parking place and was preparing to fill it, I found there were 2 small fingerlings still alive after 6 weeks with no food, no aeration, no waste removal at all. One of those 2 did not survive, but the last one did. And so he became a favorite. And he was basically, when we put him back in the tank with the rest of the fish, he was the runt. However, in our push towards automation, I trusted my automation one week a little bit too far. I had just installed the automatic fish feeder. And there is a consequence of automatically feeding your fish. They will eat almost everything you give them, and then they will produce solids to match. Well, that in and of itself would not have posed a problem had I been daily monitoring the system. But we went 4 days without visiting the bus. And an unexpected challenge arose. If you'll take a look, right behind that kind of cattywampus pipe there, you'll see a timer there, and it's got a nice little long plug adapter on it into which my pump is plugged into. Little did I realize the weight of that assembly was such that it pulled the timer out of the outlet strip on one day, and within 3 days of non-operating pump, our fish were all dead. Catastrophic die-off. We lost all 80 of our fish, except Lazarus was still alive, hiding under one of the aerators. We have since restocked, and we are now in the process of replanting. We've had to, again, in that instance, we had to completely gut the pond and the garden space. We rinsed but did not completely redo the hydroton media, and I think that's what we're running into now with the pH. The interesting thing is, and the walk away that we take from this is that while automation is really awesome and it can do some great things, without hands-on daily reviews of these things, we run into issues where the automation takes on a mind of its own in a way, and you end up having failures we didn't account for. We have since acquired new timers. They are much lighter. We're also going to be moving our control board down to the center of the thing so we can reach it and monitor it and take care of it much better. We've also invested in a new digital meter for our pH, EC, and temperature. So we've just implemented that this week. just to give you an idea, this was during the refit in the upper left corner. We completely redid the liner, actually took the beds out and then reinstalled them. We had discovered that those crossbars up there, because this is a bus, in the original build, we had to leave those in place for structural stability. We cut our slots underneath in our liner a little bit too long, so we could only get a little over 150 gallons of water in the system. We've since repaired that, and it's been interesting as we've gone forward. A few little last minute things to touch on. Ongoing research and current challenges as we go forward, and the things that we have discovered. Most hydroponic systems that we experimented with early on experience a constant issue of clogging in the tubing because they typically use 1/4 inch or smaller tubing. And so if you get any solids in your system, or even the nutrients and the salts within your systems can clog those lines really often. And so you're forever spending man hours and labor to actually clear those lines to keep them functioning. Now, aquaponic systems can be subject to the same system. However, we took a different approach. Instead of trying to control every detail, we wanted to open up the system to allow it to work in as much of a natural system as we could. So we made our tubing, most of it, except coming down from the manifold for the cylinder pieces. Those are our weak point, but everything else is large. We're using a 1/2 inch line to run our water up and into the manifold where it drops down into the verticals, and we're using 4-inch tubing for our manifold to make sure that we can have structures in there for the nitrifying bacteria to have a home. Additionally, we realized that if we can deal with the larger volumes through our flow tubes, we can reduce the amount of times that we need to do water changes. And just for the little bits of information, one side effect we hadn't anticipated, the bus gets hot. We've insulated well, and we're currently staying about 20 degrees below ambient temperature. When our ambient's outside at 120, we're holding inside 100 degrees without air conditioning. Additionally, we've noted recently that because of the way we closed in the bus from the rear towards the front, the last room, there are 4 rooms in the bus, that 4th room stays sometimes 15 degrees below outside temperature, simply because we seal it really well. So we've had real good results with that. The one thing that we're working on now is to getting the solids to be drawn out. We've added circulators in the bottom of the tank in order to push the solids back up into solution so that the pump can draw them out into the swirl filter that we've just involved. We are not attempting to create a closed environment. This bus is intended to be a STEM artifact. We take it around to schools. They get to come in, they get to visit with us, and we are also working on a small project that would basically be 3 of the verticals with a small compact corner aquaponics unit. It will include a small fish tub, a planting bed, 3 verticals, the pump, lighting, everything that a classroom could actually have, and actually have the kids experiment with it and learn how the system works, as well as learning the husbandry of the fish and the plants. In the future, as we work out the 2 greatest issues that we face, one is power. While we are now stable with our power usage, and we have a net positive result in the morning after a long night's running, we are still struggling to make sure that we can have enough power to go. Our goal was 3 days. We're nowhere near that yet, but we're approaching it. And second has to do with evaporation from the water system. Early on, with the leaks, we were having leaks in the system, and we were running into a lot of evaporation. As much as 25% per week of our water was evaporating out. We have since taken some other steps to reduce the possibility that water can actually get out, but we've also added a dehumidifier that will capture some of the moisture that does go into that room, because it gets very, very humid. Anybody here been to Biosphere in Tucson? No? Okay. Yeah, you did. Okay. Did you happen to go through the tropical garden?
Oh, yes.
And you remember how humid that was?
Oh, yeah. But I've been in rainforest before, so.
Rainforest, right. We get humidity upwards of about 70 to 80% inside the bus while everything's running. So the humidifier is we're hoping, going to be a way to recapture some of that 25% of evaporation we're experiencing. These are all elements that we're anticipating are going to be challenges on the habitats that people are going to have to set up, be they on the moon, on Mars, or in the ISS, or in Gateway. As we move forward with these challenges, EarthSeed wants to be on the front end of that, to be able to provide information as well as have people join us to be a part of it. We are a 501c3 recognized organization looking for volunteers, helpers, anybody who would like to join us. And as others have echoed, we would love to be part of a network that shares this experience and knowledge that we've all been working on over the last 10 and 15 years as these technologies have come to the fore. Thank you for your time. Any questions? Yes.
Is it on your address, is that SACE or should it be SPACE?
It should be a P. I'm sorry. Thank you for getting that.
Okay.
EarthSeed.space.
Very good, thank you.
And the explanation for the duck. When I was a young father, and I think we had taken the kids to see one of the Donald Duck films, and I got home, and since my first name is Donald, the kids grew into this habit of calling me Danny Donald Duck. I recently was party to an ASU theater presentation. I was a last-minute addition, and I played the part of an introductory character who played the maintenance engineer for Luna City. I was Ducky, the maintenance engineer, and so the duck stuck. Yes?
So why aren't you using some ambient light so that you can save energy and reduce the heat from your fluorescent lights?
The objective of the bus was to simulate an environment in a cave on the moon, to reduce the potentials and to identify issues that we would face, whether it's a cave or whether it's a habitat. Ambient light coming in defeats the purpose of being able to observe and report the effects of our artificial lighting as it would be applied in a greenhouse on the moon and Mars.
However, if you use fiber optics, you can still bring in outside lights.
That is true.
Cave, into any of
That is absolutely true. However, our budget is rather restricted.
Yeah. Only money.
Yes.
Is it smelly with all those open fish ponds?
As a matter of fact, one of the most glorious and pleasant discoveries that we have made is that as long as the pond is kept within the normal range of pH, temperature, and solids and so forth, it doesn't smell. You walk in, you smell the water environment, you notice the humidity, but it doesn't smell of fish. When the children came through the bus, they didn't know there were fish there until we said, look underneath. And only then did they realize there were fish in the bus. It's one of the most unusual things we encountered. Yes, and then over there.
If you're using this as an analog for the moon, I mean, I know you can't model it here, but have you thought about, or what can you tell us about the different water flow properties at 1/6 gravity that you would face on the moon for your hydraulic system? In terms of pumping water and draining water and
one of the things that we are working towards, and part of the reason, if you noticed the manifold that sat by the ceiling, the 4-inch pipe across the top, and then the vertical cylinders that come down, that whole design is on purpose because what we're anticipating is that we won't be able to depend on gravity. Whether we start on the moon with 1/6, or we go to Mars with 1/3, or we go out to Callisto, Ganymede, and Titan, we don't know what the effects or the availability of the sufficient gravity to provide are going to be. We wanted to build a system that could gradually transition into a completely sealed environment. The grow beds are built in such a way that down the road we hope to lay a film across the media. The cylinders are designed so that we can gradually begin connecting them with hard tubing so that the whole water flow system will be pumped and semi-pressurized. so that by the time it gets down, the final two will actually drop through the film and through the composting and into the grow media, where it will then pressurize that and then ultimately be pushed back down into the pond area, which will have its own cover on it to keep the water sealed in. That'll eliminate a lot of our evaporation issues, but we're gradually working to that end. So,
Thank you.
yes.
I mean, Mrs. Parker, because I came in late, but what is your optimal pH range?
We're working to get our pH right now. We're sitting at actually 9. We can't get anything to grow or stay growing for the time being. But as I mentioned to the rest of the group, we believe that's because our media bed is probably contaminated with solids to such a degree that it's holding our pH too high. We're preparing to redo that media bed and hopefully bring our pH back into the range of between 7.5 to 8 is our target. We were at 7.6 when we fired the system up in March, and that held until September. And then we started seeing a gradual increase.
Jerry Tennant of Electric Universe fame is a practitioner in Texas and Arizona, says that's the optimal range in human beings for recovery and healing, 7.6, and the physiological is like between 7.35 and 7.45 is the norm.
Right. The challenge is that on the pH, we have to balance the lower pH that the fish seem to like in the 7.2 to 7.6 range with the plants that prefer a higher pH depending on the plants that you have. Some actually go well up into 8.5 as a preferred pH for their growing cycles. So one of the things that we're working on is trying to try plants out and see if we can encourage them to work with the pHs that we can work with. Yeah.
Have you thought about, I know it's a power consumption thing, but have you thought about putting an AC unit inside?
I have 2 window unit air conditioning units inside the bus. When I do connect to shore power, we use those.
Gotcha.
We actually volunteered to help at the MDRS next week on their refit, and they graciously accepted that I could drive the bus up there. It will be the first road trip for the bus in an open space, and it will be its first 100% off-grid experience. So we're going to be really documenting everything to see how well the whole system performs without having to fall back on shore power. I do, however, have a 4K generator on board, just in case.
I'm thinking about the heat just because it will dry the plants a lot more. Is that a factor that you said of concerns, or is that?
Heat isn't so much.
Okay.
Because in a tropical environment, you're hoping for between 75 to 85 degrees as an optimum for the planting media. We've actually been able to get very close to that in the temperature ranges we're getting now in Phoenix. The downside is that temperature can quickly spike. So what we're looking at are alternative issues. And one of the side thing with this is that the challenges of any enclosed habitat on the moon or Mars are that the equipment that you're going to have in that habitat, plus the people, plus any animals that you may nurture within that habitat, are going to create heat in an enclosed space. So we're actually taking that on as another challenge. How do we go about dissipating that heat or converting that heat into usable material or usable energy that we can then turn around? So we're looking at a few things. That's part of the reason that the current waterfall that we use underneath as part of our bell side is only about 18 inches long. We're going to extend that the full length of the 8-foot bed. That will help to cool water as well as cool the environment, we're hoping, as well as it goes through. So little things, and what we're finding is it's the tiny changes that seem to make the biggest differences. Throwing a lot of technology in there, air conditioning, dehumidifiers, all this kind of good stuff, all that does is add heat and power usage. So what we're looking at is what does nature do for these kind of things? We're also anticipating that once we get our full density of all 8 grow beds fully dense of our plant work, we're going to see a difference in our temperatures as they will start aspirating and drawing all that temperatures out. So at least that's what we found in the initial research. Anything else?
I guess on a follow-up to that,
Yeah.
with the gravity question, do you, I guess, anticipate or imagine collecting water up higher? Or, like, I guess, how solid is the water containment unit when you're talking about lower gravity? Is the water itself going to be bouncing more when it gets out of the waterfall? Is it going to be collected more on the ceiling as opposed to mid-level?
We probably won't have, in a low or no gravity environment, you won't probably be able to run a waterfall of any sort. Primarily because there's insufficient gravity for the water to follow a decent trajectory into the pond.
Okay.
You're gonna have things like bouncing off of each other and could end up going sideways. And so a lot of what we'll be doing is working on building a top for the fish pond, and then eventually that linear waterfall will be interchangeable with an actual pair of tubes that come down direct into the pond. So the idea is to design the system so that it can function in zero gravity just as easily with minor modifications as it could be portable into a full gravity situation.
Awesome, thanks.
Thank you. Thank you for your time.
Thank you.